Good evening, guys. Am I audible? Is my screen visible? Good evening. Yes, good evening. Is it audible, guys? Thank you. Thanks for the confirmation. So, today is day 11 of this Data Science Naan Mudhalvan Virtual Internship. Okay, I welcome you all on behalf of Pantech elearning. Can we start the class? The certificate it will be issued soon in 1 or 2 days, so please wait for it regarding the Python internship certificate. Okay, so have you guys started the assignment which I have gave yesterday? So yesterday is day 10 class and I have given you the assignment 2. Have you guys started doing it? So please try to complete it before Monday, okay? So that will be the last day for assignment 2. So make sure you are completing it before that. Okay, so can we start with the class? And in yesterday's class we have seen about the introductions of machine learning algorithms. So how to choose it, what is the nature of each algorithm. So we are discussing about it, right? So we have completed 2 algorithms. One is linear regression, another one is logistic regression. Today we will continue with seeing some of the algorithms and seeing the metrics, which is nothing but the model evaluation. Okay, so that's what today's plan is going to be. So we'll start with the class today. And in machine learning we are seeing about no, it's not same, so it can be different, no issues. I have just shown you for that example. Okay, that's a different data set. Okay, don't worry about it. So how to choose the right machine learning algorithm? So the factors you have to consider is the nature of the problem you are solving, okay, nature of the algorithm and performance comparison. Okay, so going into the nature of problem, as I told you yesterday's class, it is divided into 3 types. So based on it you have to select the algorithm, whether it is classifier or regressor or clustering problem. Okay, and when you go into the nature of algorithm, if you are going to choose an algorithm, you want to know about that algorithm actually. So we have seen about the linear regression and logistic regression in yesterday's class, and today we are going to see about starting with the support vector machine. Have you guys heard about it, support vector machine? So this algorithm is designed for both classification and regression. So from now on we are going to see some of the advanced algorithms which is used, which has the options for performing the classification as well as regression. Okay, so this support vector machines are a popular and powerful supervised learning algorithm used for classification and regression. Okay, so this support vector machine are based on the idea of finding the hyperplane. So they are telling a word known as hyperplane, so that separates the data into different classes. For example, okay, I'll show you with the image. So SVM is a versatile algorithm and can handle both linear and non-linear data set. So this is what a support vector classifier will do. So in support vector machine we are having classifier and as well as regression. Okay, so the classifier, what it will do is, for example, if these are one group of output and these are another group of output, it is going to find a line which separates both of these. Okay, this red line which is in between these 2 lines, right? So I'll tell you what this dotted line is. Okay, but before that, the center line is called as hyperplane, which we have mentioned here. So this is the hyperplane, which is the boundary for separating these 2. Okay, then what about these dotted lines in both of the sides? So this dotted line is called as support vectors. So these vectors are for supporting this hyperplane. So how is the support vector is fitted? Okay, For example, I'm having a blue point and green point. For example, two output, one is blue, one is green, and it is separated by a hyperplane. Now I want to create a support vector, and how it is done. In green point, okay, which is the closest point to the hyperplane? This is the hyperplane, which is the closest point among green, this one, right? So the support vector is passed through that point which is close to the hyperplane. That single point or multiple point which is nearer to the hyperplane, that will be the support vector. Okay. So here for the blue point, we will be having the support vector here because this is the closest point to the hyperplane. So that's how this line is drawn. Then comes the question, okay, so if you are having linear data, you can just directly draw a line and find the hyperplane like this. For example, if you are having a data set like this, where the green points are separated like this and blue points are separated like this, how are you going to draw a line? You cannot draw a line, right? Like this, you cannot create a hyperplane. So how are you going to handle this non-linear data problem? So for this, there is an option in support vector machine which is known as kernel. So for example, if this is the point, okay, you cannot create a hyperplane. So what it will do is it will try to convert this point in a 3-dimension. So see here, these red points are above the plane and these green points are below the plane, and it is trying to classify them based on it. Okay, based on the kernel option, you can convert them into a 3D format with some other feature so that it can be categorized into two different plane. One will be above the plane, one will be below the plane. Okay, that's what the main advantage of this support vector machine. Like this, for example, it will try to find another dimension where it can split both of these. Okay. So how this support vector machine works? For example, see here, I am having 2 points like this. I can draw this blue line, I can draw this red line. Okay. So both of them are right? Both of them are correct because I am just going to separate them. So how will you find the best fit? Okay. So based on the support vectors only, we are finding the hyperplane. Okay, it should be in the center, and these points should be whichever the points which are in the end or near to the hyperplane. So that will be the best fit for this hyperplane and support vectors. So for classification, there is a formula for like this here. Okay, this formula will be applied. So you'll be having two values. So the group which is to the left side of the hyperplane will have a negative value, the output. Okay, and the right side will have a positive value. So which means when you want to fit a point, if you are giving a new point, okay, so if the point is positive, it is going to be this one, for example, red one. Okay, if it is a negative value, then you can classify them as green. Yes or no question, classification problem. So this is how the support vector classifier works. So for support vector regressor, in support vector machine or classifier, it will try to find a hyperplane and fit the support vectors and try to find either it is positive or negative and split them. Okay, but regarding support vector regressor, what it will do is it will try to create the E tube, okay, epsilon tube. So it is a tube which has this hyperplane and support vectors, but here the idea is it will try to fit maximum points inside this epsilon tube, inside the support vectors and hyperplane. Okay, it will try to fit the point. So based on it, it will create a regression line. So which fit is the best fit, it will create that and do the regression problem. So that's what with support vector machine. Is it clear regarding support vector machines? Is it clear, guys, regarding support vector machine? Do you guys have any doubt? Is it clear? Can we continue with the next algorithm? Okay, I'll explain it briefly once again shortly. Okay, the support vector machine, okay, the idea behind it is trying to fit a hyperplane. Okay, to create a line or a hyperplane, they are calling it as a plane. Okay, it is a line which separates the points into two groups, okay, based on the plane. and there is something known as support vectors. So how this is doing is, we are creating a hyperplane, and this support vector, how it is fitted for both of these points. For example, this blue point is a group and this green is another group. How this hyperplane is fitted? So this this support vector should pass through that, like the point which is near to the hyperplane. This is the hyperplane for green point. This is the nearest point green it is present, right? So the support vector will pass through this one. Similarly, on that side, how are you going to find the point? It is passing through this side of the point. Okay. Okay, how to fit the best line? For example, here you see in both of this, okay, we got two different lines, right? So based on the support vectors, okay, based on the support vectors, which point is the later, like which is nearest to the hyperplane, this fit is generated. Clear? So next we are going to see about decision tree. Okay, so we are going to start with a tree based algorithm. So this is known as a tree based algorithm. So decision tree is a supervised learning technique, okay, that can be used for both classification as well as regression, but mostly it is preferred for solving classification problem. So decision tree usually mimic human thinking ability, like our human brain, or it is going to have that thinking ability, like how it is going to take decision, okay, based on like a conditional statement, whether this or that. Okay, it is a tree. So what is a tree based algorithm? Okay, it is going to go with many branches, so that's what the name comes, decision tree. So it is going to create many nested conditional statement and try to fit the points. So decision tree usually mimic this ability. The logic behind the decision tree can be easily understood because it's like a tree like structure. For example, it is like this. So the starting will be a decision node, okay, root node. It is also called as a root node because this is the first node you are starting. So it is going to split them based on the points it is having. So it will, like further it will decide. So how much it is going to split. So when it reaches an end, okay, it is called as leaf node. Okay, I'll tell you with the example, but this is how this thing is going to be. So if it splits, then it is called as a decision node. Okay, it starts with the root node, it has many decision nodes. Once it ends, it is called as a leaf node, like a tree. You are having many branches, but it will end in a leaf, right? So in that leaf, after that, there is no splitting. That's what the idea behind this decision tree is. For example, this is a common data set which is used for explaining the decision tree. I'll tell you explaining this. So this is a classification problem. The output is yes or no. Okay, this is what the prediction is going to be. So we are having some features known as weather, temperature, humidity, and wind. Okay. So for example, the decision tree will first try to start with this weather as the root node. So what is a root node? It is the starting node. Okay. It is going to take the weather as the starting node. And in weather, what all things present? Try to find what all unique things present in weather. So we are having sunny, cloudy, rainy. Okay, three things. Sunny, cloudy, and rainy. So it will try to like accommodate this sunny. It comes no here. Sunny, it comes yes here. Okay, cloudy is yes, cloudy is yes. Rainy no, rainy no. Rainy yes is coming. But you see in cloudy, it is all yes there. Okay. Can you see it? If it is cloudy in this weather, it is yes in all the places. So this cloudy will become a leaf node. Okay, there is no splitting further than that. But see here, it starts from this weather and it's trying to split their points. Okay, once this leaf node is came, it will terminate. But regarding the other things, it will go and take the next column or next feature. Okay, and it will try to split them based on each feature. It will go till the end, till it completely neutralizes all these leaf as the leaf node. Finally, it will do the prediction. So, but how are you going to decide? Like, for example, whether the decision tree will start with this whether it is a good choice, or it will be better if it starts with the temperature as the root node, or it will be good if it starts with the humidity or wind as the root node. Okay, based on that, you go for further splitting with these columns. How are you going to decide that? Okay, here comes the mathematical thing behind it. Is it clear till now regarding the working of decision tree? How the nodes are created, how it is branching, how the leaf node is achieved? Give me thumbs up, guys, so we can see what is the max behind how to select the better root node. I mean, like, we are not going to select it, how the decision tree is actually doing it. So it can start with this as a root node, or it can start with this as a root node and go with all these features. How the decision tree is deciding which is the best thing to do. So there is something known as entropy calculation. So based on the probability of these things, okay, there is a calculation with the help of logarithmic 2 to the base 2. So we are calculating a value. This entropy is a value. So with this entropy value, there is another calculation which is known as information gain. Okay, which is done with the help of this entropy value. Okay, so you'll be getting a information gain value for each of this root node. Okay, if you start with weather as the root node, what is the value? Or if you start with the temperature as the root node, what is the entropy and information gain? This is the final achievement we'll get for all these columns as root node. Once you get, for example, see here, this is for outlook or weather. Okay, it's a different example. Okay, this outlook is nothing but the weather column. Okay, so the same sunny, overcast, rainy. So this outlook got a gain value of 0.27. Okay, the temperature got a gain value of 0.029. Okay, humidity got this value and play golf got this value. So based on these values, so what it is taken, highest the gain value is taken. Okay, if you have a gain value which is high, it is going to taken into consideration as the best for taken as a root node. Okay, so based on it, it is splitted and it is categorized as yes or no. Okay, this is what happening behind the decision tree, and this is how it will select which feature is the best one, and it will do multiple iteration, multiple branches to finally normalize all the output. Clear? Can we start with ensemble algorithms? So here we are going to see about 3 algorithms. So what is ensemble algorithm? So ensemble algorithm, these are algorithms which uses multiple models. Till now we are using one algorithm, one model, but here it is one algorithm, but it will use many algorithms or many model inside of it, like multiple things are happening in the same algorithm. So there are 2 methods inside of it. One is known as bagging, another one is known as boosting. Okay, so bagging is like separating, like if you are having like your entire data set, it will be split into parts and given to different model and try to get the output based on it. That will be bagging, separating them into bags and giving and do the process. And for this there is a famous algorithm which is known as random forest. There is both classifier and regressor for it. When you go for boosting, okay, so boosting is like for the every time the model run, it will give a output, so it is going to compare with the original answer, and if it is wrong, it is going to improve the answer. Okay, it is like adding a weight and improving the answer. So there are some algorithms like AdaBoost and XGBoost are there. So we'll try to see these algorithms, starting with random forest. So when will you call a forest? What is a forest actually? Or if there is multiple trees, you can call it as a forest, right? Simply, for example, if there are many trees, you can call it as a forest, right? And then the name suggests random forest, so it is a random forest. So what that defines? So random forest is a popular algorithm used for classification and regression. It is a ensemble learning method. Okay, this is a ensemble learning method that combines multiple decision tree. What is decision tree? We just seen about the decision tree, right? Tree based algorithm. But these are known as multiple decision tree. If you are having multiple trees, you can call it as a forest. Okay, and as I told you earlier, this is a bagging method which is going to take the or split the data and give it to separate model. So it will randomly split your data. Okay, and create multiple decision tree. Previously we have seen about one decision tree and its output. Here it is going to use multiple decision tree. So it's going to randomly take your data, split them and giving to different model and get the output of them, and it is going to, like, based on all the output, it is going to give you the final output. Clear? So the random forest algorithm works by building a large number of decision tree, each using a randomly selected subset of the available input feature and a randomly selected subset of the training data. So it is going to split it into different parts and give it to the algorithms and get the output. These decision tree are then combined to make the prediction on new data. So how the output is decided? See here, this is what a random forest algorithm will look like. This is one decision tree, this is another decision tree, this is another, it will go on. It will create multiple decision tree. So for example, if it is a classification problem, okay, and you are classifying whether the target is 1 or 0, for example, okay, imagine the output is 1 or 0, this algorithm decides the output as 1. This algorithm decides the output as 0. Finally, there is a third algorithm which decides the output as 1. So what is the majority of the vote here? The output 1 is the majority vote. So the output will be 1 as the answer. Okay. So if you are going for a regression problem, okay, you are taking a temperature, okay. So this one tells it is 32. This one tells it is 34. This one tells it is 33. Okay. So it is going to take the average of it and give you the output. Clear? How this random forest algorithm works? Is it clear, guys? How random forest algorithm is working? So it is going to take multiple decision tree, split your data and give to them, ask it to predict and give the output. So based on all of it, if it is a regression problem, take a mean or average of it. If it is a classification problem, what is the majority of the vote? That will be the output. Is it fine? Okay. So next one will be AdaBoost. So this is which type? Whether it is bagging or boosting, guys. Tell me in chat box quickly. Okay, so starting with AdaBoost. So this is a, yes, correct, it is a boosting type algorithm. Okay, so AdaBoost algorithm, short for adaptive boosting. So it will going to adapt for the output. Okay, it is a boosting technique used as an ensemble method in machine learning. It is called as adaptive boosting as the weights are reassigned to each instance with higher weights assigned to incorrectly classified instance. Okay, so I'll explain you this point. The basic idea behind AdaBoost is to iteratively train weak classifiers on different subsets of training data. Okay, and assign higher weight to the sample that were misclassified. In the way, the subsequent weak classifier focus more on difficult samples that are not correctly classified by the previous classifier. For example, you are having a model. For example, you are having decision tree. Okay, if you are using AdaBoost. Okay, so this is giving an answer, and it is going to be compared with the original answer. Okay, you are having y train and x train and y train, right? So it will compare with the answer and what all the answers are wrong. Okay, that is called as weakness. So it is going to given to the model 2 with higher weight, which means these are trained much more, and this algorithm is asked to do the prediction. So this will give some answer which will contain some more weakness. Okay, for example, if it has 20 weakness, this may give somewhat 10. So that 10 alone is given some more highest like weightage or weight. Okay, so it is asked to do the prediction. So this will keep on going till it reaches the maximum output. Okay, this is what known as ADA boost. So that's what is happening here. The basic idea behind it is iteratively train weak classifier or different subset. Okay, so the misclassified or the wrong output are given with higher weight so that it can learn and try to give the correct answer. Okay, it will try to assign, for example, if you are having 1000 rows, it will take some 500 rows and give it to the model, and in that 30 are misclassified. So it will take that 30 given some higher weight, and along with that it will give some other 500 rows, the different one, and it is going to repeat this till highest number is achieved. Okay, the original data set given, and then the weight is updated, then again the weight is updated based on the flaws. That's why it is going to improve much more when it is keep on running. This is what known as boosting or adaptive boosting. It is adapting based on the output failures. Okay, and next one is known as extreme gradient boost or XG boost. Okay, so this is the final algorithm we are going to see. So XG boost or extreme gradient boost works by building a series of decision tree in a gradient boosting framework. Okay, so there is not something known as gradient boosting is happening here. Decision trees are used. So in this framework, each tree is built to correct the errors of the previous tree, with the final prediction being the sum of the predictions of all the individual tree. Okay, so another important feature of XGBoost, it can handle missing data. Okay, if you are having missing data, if you cannot do anything to that, you can use this XGBoost. Okay, it can automatically learn to handle the missing data by assigning different directions in the tree. Okay, and it will try to find the best split in the data. So based on the output from tree 1, okay, if the answer is wrong, for example, the output you have to predict is 1200 and it is predicting as 700. Okay, so that 700 is set as a new value and given to this algorithm. Okay, and it is trained on that, and it will try to like sort the difference. So this will keep on running. So this is known as extreme gradient boost. And adaptive boosting, we are just giving more importance to the flaws and making it to make it to predict correctly. Here the value which is predicted wrong is given as such, and what is the difference it is trying to improve using XGBoost. Clear? So we have completed some of the important algorithms and the math behind it. So next, the final factor to be considered, which is the model evaluation. Can we see about the model evaluation task? How to compare different models. So in classification or for regression, we are having many models, right? How will you decide which model is the best one? There comes the use of this model evaluation. Okay, we are going to evaluate the model and give it some score for it. Can we start, guys? So starting with model evaluation. Model evaluation is a process of using different evaluation metrics to understand a machine learning model's performance as well as its strength and weakness. So the model evaluation is important to assess the efficacy of a model during the initial research phase, and it also plays a role in model monitoring. Okay. So based on the problem you are going to solve, whether it is a classification problem, you can go with these tasks, or for regression problem, you can go with this one. For classification, you can go with accuracy score calculation, precision, and confusion matrix to decide how much it is predicted correctly and how much wrong. For regression problem, you can go with error calculation, which is the mean squared error, or there is something known as RSME, which is root of mean squared error. You can calculate both. So the accuracy score for classification problem from sklearn.metrics, import accuracy score. This is from metrics. Okay, all these calculation evaluations are from metrics. So once you train the model and get the output, So in the end of the session, I'll show you practically how we are using a model, how to fit and train it, because tomorrow we are going to actually go into project. So once you've done the prediction, the machine will give some answer and I will store it in the y predicted value, y predict. Okay, and this is the true value. So this accuracy score will compare both. Okay, this is a classification problem. It is going to compare how much answers are correct and how much wrong. Based on it, it is going to give you a score, and if the score is high, okay, you can decide it is a good algorithm. Or if you are having 3 algorithms and which algorithm has the highest score, you can go with that. This internship is completely free, no worry about it. And regarding the precision, you can go with classification report from sklearn.metrics. Import classification report. It is going to give you many report. I'll show you. Okay. And the next one will be regarding this confusion matrix. Okay, you will get accuracy, recall, precision. So how it is calculated based on the true positive and true negative value. So what is known as true positive, true negative, false positive, false negative. For example, see here, this is what known as a confusion matrix. I told you this confusion matrix. See here, we are having the predicted value and the ground truth. Ground truth is the original answer. Predicted is the answer predicted by the machine. So if they, like for example, you are having 2 tasks here. One is positive, one is negative. 2 output. If the positive is directly predicted as positive, it is called as true positive. Okay, the original answer is positive. The predicted answer is also positive, so the output is true positive here. If the original answer is positive and the answer predicted by the machine is negative, which means it is false, right? So it is called as false negative. If the original answer is negative and the machine predicted as positive, then it is called as false positive. And negative negative means it is correctly predicted as true negative. So these two are correct predictions, these two are wrong predictions. This is true positive or TP, true negative TN. Okay. False positive, false negative. Based on it, accuracy, recall and precision are calculated from classification report. So this you can get it. You can also do confusion matrix from sklearn, and you can plot it in a Seaborn heat map. Okay, so you can get this graph where how much correctly predicted, how much wrongly predicted. When you go for error calculation, this is for regression problem. To get this root mean square error, you can go with R2 underscore score from matrix. You have to pass the y true value and predicted value, so it is going to give you the output. Okay, so can we see, guys, I have one classification and regression problem created. So I have just done some simple pre-processing and I have splitted them into train test split. So can we start with this one, guys? Can I get thumbs up? Can we start with this one? So you see here, we are having train test split. Okay, so this is the hard data set, which is the classification problem. The output you have to predict as 0 or 1. So I have stored x and y. Okay, and then I have splitted them into x train, x test, y train, y test. So now first I am going to use, this is a classification problem, I am going to use support vector classifier. This is the first algorithm. Okay, support vector classifier. So how to get it actually? Support vector machine, you have to get the support vector classifier from sklearn.svm, which is support vector machine. Import capital SVC, this is for support vector classifier. If you want regressor, it is SVR. Okay, support vector regressor. So once you import it, you have to create an object for it. I'll create it in the name model1. So okay, this is the first model I'm going to use, support vector classifier. Once you import and store or created an object for it, you can use dot fit option, not fit transform here. This is fitting. Fitting is something like training the data. This is what known as training data. So you have to pass the x train and y train value so that the machine can learn for these questions. This is the answer. This will happen in the dot fit or the training part. When you want the machine to give the answer, you can go with model1.predict. That will be the predicted answer. But here we are going to give the question alone, which will be the x test. And this is stored in the variable answer. Okay, so I'll run this. Clear? So from sklearn.metrics, I'll import the classification report, which you have seen now, right? This is a classification problem. You can go and get this classification report. And the report, okay, in this object I have to pass this y test, and this is the original answer. Y test will be the original answer, and answer will be the answer predicted by the machine. I can show you guys. I'll print the answer. So it has predicted 100001, okay, and I can print the original answer, y underscore test. So these are the answers for X test, okay. This is the original answer, this is the answer given by the machine. So now we want to compare. For the first question it is given as 1, here also 1, so it is correct. So we are keep on going to correct it. So when it is wrong we are going to give it, like, reduce the marks, okay. And in this, if I run this and print this, so based on the true positive, true negative, false positive, false negative, we can get this precision value, recall value, F1 score and support value for zeros and ones, okay, how much it is done. If you want a percentage or marks, you can go with accuracy score, okay. I'll run this from sklearn.metrics, import accuracy underscore score, and the score I can pass it, and if I print this, you see here we got nearly 0.88, which is like 88%. So I can print this with multiplied by 100. So with this algorithm, support vector classifier, we got 88% correct, okay, which means here 12% is wrong answer, okay. You can actually see how much is correct, how much is wrong with the help of this sklearn.metrics, okay, import confusion underscore matrix. I'm going to plot a confusion matrix, okay. I'll do it here without this confusion underscore matrix. I'll pass this y original answer and the answer given by the machine, and if I run this, see here I got an array 85, 17, 6, 97. So in 85 places, this is true positive, this is true negative, this is false positive, this is false negative, okay. You can plot it in a C-bond, SNS dot, okay, heat map. I can store this in a variable, or I can directly pass this, okay. So if I run this, it is going to give me a color map. If I want the values actually present, I can set annotate equal to true. Annotation, I'll set this to true. It is going to show me the values here, okay. So in 85 places, the 0 is correctly predicted as 0, okay. In 97 places, the 1 is correctly predicted as 1. But in 6 places, okay, in 6 places 1 is predicted as 0. And in 17 places 0 is predicted as 1. So these are the 12% which are wrong answers, and these are the 88% correct answers. Okay, this is how you can evaluate a model. So for example, next I am going to use another classification algorithm. This is decision tree classifier. So I'll run this. So same thing, I'm going to create a model or object for it. I'm going to fit it with xtrain xtest, and I'm going to ask the model to predict or give answer for xtest. It is stored an answer to. So the accuracy score I'm calculating with the help of original value and the answer predicted by the machine. So this is 0.98, we got 98%. So which one is best, guys? Here 88 or 98, which is best? This one is best, right? Clear? So I can do the same for here also. So instead of this, I can pass the answer 2 and compare. Okay. Clear, guys? So next, this error calculation will be for regression problem. So I have another regression data set here, the same car data. So I haven't done any pre-processing or EDA. That's for the assignment. And here I am going to use one algorithm. See here, guys. I am splitting it into xtrain, xtest, ytrain, ytest. The final output here is the regression, which is the price prediction, selling price prediction. Okay. So the model first I am going to use is linear regression. Okay, this is the regression problem. I am using linear regression. So I am fitting the data and then ask it to predict. Okay, if I run this, it is going to give me an output. I'll print it. Okay, these are values for all the xtrain, x test. Okay, so I want to compare it. How will I compare? I can go and compare with R2 underscore score. Okay, So I'll run this. So the original value and the answer predicted by the machine, and I got nearly 0.84. Okay. So you can go and do with another algorithm. This is random forest regressor. This is another regression based algorithm. Okay. So here I am fitting it and predicting and getting the answer. So I can compare them with the help of R2 score. So with that I can decide the best algorithm. Okay. So this is how we can do for both classification and regression. So in tomorrow's class we will start with a project. Okay. So in the next two class we are going to see one classification project and a regression project, and then we move into clustering algorithm, okay, or unsupervised learning, and then into deep learning, and then with natural language processing we'll complete this internship. This is a 20-day internship, and after this 20 days you have a 10 days time for doing a project, and you are having a prize money also. So make sure you are developing some idea with the help of data science and do some project which is actually useful and innovative to win the prize. Okay. So tomorrow we are going to see a project where we apply all the things we have learned in the past few days. We have seen all the pre-processing tool, the model, the metrics, all of the things we are going to actually apply from the start to the end. We are going to apply and try to get the output. Okay, we'll start with a classification problem or project in tomorrow's class. So that's it guys. Thank you. Thanks for watching. We'll see you in tomorrow's class.